Hello, uh, welcome to our webinar. Good afternoon or good morning, good evening, wherever you are in the world. It's very nice of you to come and sign on for our webinar. Just a couple of quick notices before we get into the content. Everyone is automatically placed on mute. That's to make sure that we don't get any feedback, background noise and those kind of things. There is a chat function, and you're encouraged to put any questions you have in the Q&A part of that, and we'll get to those at the end of the presentation. The presentation is being recorded and will be available to participants online on demand after the webinar is concluded. So today's webinar is about a new version of the standard ISO 13849 Part 1. It's edition 4 of the new standard, and there are some very significant changes. So our intention during this webinar is to go through briefly, because we don't have a massive amount of time, of course, but to briefly go through some of the most significant changes that there are in edition 4, and there are some very significant changes. My name's Stuart. I'm Stuart Robinson, and I'm certainly not going to read everything that's on the screen now. I'm simply going to say I work for TUSID, and I'm based here in the UK, but I have some responsibilities beyond the UK with our global IEP team. And I've been focusing on safety-related control systems for something in the order of 25 years now. So it's quite a long time since I've been focusing on safety stuff. My background is a control systems engineer, and I've concentrated mainly on machinery, but I do get involved with functional safety in other sectors as well. So today's webinar, I'm going to start with a bit of history, and I'm doing that because there are some things back in time at the beginning of the process for 13849 that have an influence on what we've still got in the standard today. So just a bit of background to explain a little bit about that. But we then will look at the structure of the new edition, edition 4, and that's a very significant change from the structure of preceding editions of the standard. The recommendations for risk assessment and risk reduction has been beefed up a little bit, so there's a bit more emphasis on that, the concept of risk assessment, risk reduction in the new version. The requirements for generating a safety requirement specification and verifying, validating a specification has been very considerably enhanced, so we'll look at that. Combinations of subsystems is also an approach that is getting much more emphasis in edition 4 than it's had in previous editions, so we'll be taking a look at that. Software, the detailed requirements of software haven't changed a lot. What has changed is where it is in the standard. That's changed very significantly, and there have been some other changes, so we'll be looking at those. A big change is what is now in the standard about verification and validation. So we'll go through that in some detail. And we have in the standard at least a mention of the management of functional safety, which is quite a departure. But we'll look at how that's dealt with in the standard, and then we'll finish by looking at the new annexes. The annexes in the edition 3 are all there, they've all been retained, but there are some additional annexes. One or two small changes in the existing annexes as well, which are at least one of which I'll touch on very briefly. So that's our agenda. So first of all, a little bit of history. The life of this standard began in 1996, In 1996, it was published as an EN 954 Part 1, which became edition 1 of 13849 Part 1. And in that EN 954, it introduced this concept of the architecture of saturated code. Didn't use that term, but the architecture of saturated controls were based on categories. Those categories are still in the standard today, still with a lot in common with the way they were described back in 1996. But EN 954 was a heavily criticised standard in some ways, by some parts. And that's existed right through to today as well, by the way, which we may also touch on. But that resulted in 1999, a SEN report, CR 954 Part 100, that was published to explain the correct use of EN 954 Part 1. And because of that statement on the screen now was used in CR 954 Part 100, it's clear from experience that there's been difficulties in understanding how this standard is to be used. And part of that was understanding how the categories should be used, how the correspondence between the categories and so on. And some of that is still there today, that's been carried through in the various editions. But in 2006, edition 2 was published. That was quite a change from 954, but had a lot of the content of 954 was carried through, of course, but there were some fairly big changes. It had some errors that were taken care of by a co-agenda issued in 2009. But as many of you on the webinar today will understand, if not all of you perhaps, that 13849 is not the only standard that deals with the topic of safety-related controls on machinery. We also have IEC 62061. And there was a project put in place to combine the contents of both of those standards, so we just had one standard. In 2015, a committee draft of this new standard, what was going to be a new standard, ISO AC 17305, was circulated to the national committees. But that also pretty much marked the end of the project to combine the two versions, because almost as soon as that document was circulated, the ISO withdrew from the project. So the project failed, and that meant that both ISO and IEC went their own way to update the versions of both 13849 and 62061. And in December of 2015, the third edition 3 of 13849 was published. That was a fairly hasty revision to take care of some things that had needed to be taken care of because of the state of the art changing and those kind of things. But at that point, the ISO began work on edition 4. Almost straight away, they began work on edition 4. And edition 4 hasn't had a smooth journey. It's been knocked back a few times, which is why it's taken so long for us to get edition 4. So edition 4 published a couple of months ago as an ISO 25th of April 2003. So that's how we got to where we are. And quite a bit of the content of edition 4 is taking advantage of some of the work that was done to create the combined version of both standards. And that explains, I think, in some ways, some of the significant changes that there are. So, and the most significant change, I guess, is it has a completely new structure. The clauses are 1, 2, and 3 are scope, normative references, terms and definitions, exactly as you would find in any standard, of course. So the detail of the standard begins at clause 4. Clause 4 is now called an overview. edition 3, it's called design considerations, but all the bits in clause 4 that were related to specification and design have been moved to other clauses, and clause 4 is where we've got some enhanced requirements about risk assessment and risk reduction by various means and so on. Clause 5 is now the dedicated clause for the specification of safety functions. It was simply called safety functions. And this is where we've seen quite a significant change, partly because it's taken some parts of different clauses in edition 3 and brought them into edition 5 where they properly belong. But there is also more detail given in the new clause 5 in edition 4 about what is required in a specification, and as we shall see shortly, it's also very, very clear that a specification has to be verified. So that's quite an important change. Clause 6, design considerations, it's where all the information about categories, MTTFD, diagnostic coverage and so on, it was called categories and their relation to MTTFD and common cause. And that's all those parameters are retained pretty much as they were. There is one change that I want to bring to your attention, which is relatively significant, but the detail is very much as it is in the existing the version 3. Shouldn't call it the existing version because it's been superseded, but it hasn't really changed in many ways. Software is now clause 7, so it has the proper place in the standard. It has its own clause. It is the content of 4.6 in the superseded version with some changes, but the structure of 4.6 is pretty much retained in the new clause 7. Clause 8 is a very, very small clause. It's quite a simple statement about having to ensure that the verification of our performance, the performance levels achieved, actually meet their targets, meet the required performance level. And also clause 9, again, is a simple statement. This is new though. The principles of clause 8 were in preceding versions, but clause 9 is a new clause to tell us that we have to consider the ergonomic aspects of design. So it is a simple statement, but it's a new inclusion. Clause 10 is where the big change is. Clause 10 has taken the normative parts of 13849 Part 2 and in clauses 4 to 11 and incorporated them into 13849 Part 1. So that's quite a significant change, and we'll go through those in a bit more detail shortly. Clause 11, maintainability, that was included in clause 9 of edition 3. It's been enhanced a little, not massively, and similarly clause 12 is technical documentation, a little bit of enhancement, a little bit taken from 13849 Part 2 as well. So a little bit of enhancement there. And clause 13, again, information for use based on what was in clause 11 of edition 3 with a little bit of enhancement. So that's the new structure. And the new structure, I think, is, in my opinion, is a big improvement. It does go through the steps, step by step, in the way that you would need to integrate safety-related controls on machinery. So it's got a very logical structure. So the recommendations for risk assessment, risk reduction in clause 4, the two flowcharts you can see now are just slightly modified versions of the flowcharts that are in edition 3. They've been pulled out a little bit more detail, but it's very, very clear that the starting point is using principles of 12100 to do identifying limits, hazard identification, risk assessment, and so on. And then the risk reduction process has been elaborated a little. The so-called three-step process has just been fleshed out a little bit. And of course, it's the step 2, where we're doing risk reduction by safeguarding, and in particular where safeguarding measures depend on control systems, that we are directed to the process detailed in 13849 Part 1. And that's the flowchart on the right-hand side of the screen. Again, very, very similar to the flowchart in edition 3. It's just been fleshed out a little, but the principles, the steps are the same. But what is now in clause 4 is mentions of the process of risk reduction depending on measures other than simply safety-related control systems. So our risk reduction comes from a combination of measures where safety-related control functions are providing us with additional risk reduction. So this type of figure appears in lots of other publications, other standards, of course, in some form or another, but we have a threshold and an absolute minimum amount of risk reduction that must be achieved, and we would drive risk reduction into the broadly acceptable level based on principles of a LARP as low as reasonably practicable and so on, but acknowledging that there will be some residual risk. So that's part of the enhanced clause 4. In clause 4, it also gives us the correctly defined PFH of an average frequency of a dangerous failure per hour. And you may have noticed, and you may already be aware, of course, that the abbreviation used in 13849 previously has always had a D on the end, PFHD, which has caused some confusion in the real world, because all of the functional safety standards just use the abbreviation PFH. So 13849 has come into line with the rest of the functional safety world and is just using the abbreviation PFH. But the values of the targets hasn't changed. The upper limits for corresponding to each performance level are still exactly the same as they are in edition 3. So that is not a change as such. But what has got much more emphasis in edition 4 is the concept of using combinations of subsystems. And the word subsystem is actually used in edition 4, so something a little different to edition 3. So it says that safety functions can be realized by combinations of subsystems, and subsystems can have different architecture. And that was actually, that concept was published in CR 954 Part 100. So it's been with us for well over 20 years in a published standard, published document. So it's been retained in examples in every version of 13849 since then. But in edition 4, it is getting much more emphasis. So this in clause 4, we shall see that in clause 5, again, there is additional content about the use of subsystems. The clause 5 is also where we'll find the enhanced safety requirement specification. And this is part of subclause 5213, and it says quite clearly that the safety requirements specification shall have the following information. So it's a mandated normative requirement. And these are just the first 5 points. It goes on to, the list goes right up to point M. So it's got a great deal of clarity on what is required in a safety requirement specification. And some other aspects of Clause 5 have also shown us some changes. There are some additional examples of safety functions, for example, some safety functions for maintenance tasks. There is a mention of a requirement about minimizing the motivation to defeat safety functions. And in practice, and this is unfortunate, I think, but it's true, when people are hurt, and that's a when, not an if, when people are hurt on machinery, it's far too often, in my opinion, far too often the case that safety functions, safeguards have been defeated in some way or another. And to avoid defeat, one of the first things that, this is in other standards as well, one of the first things that we ought to be thinking about is minimizing the motivation, designing for failure-free operation so people are not motivated to try and defeat. That's now in 13849 Part 1. There is also a clause taking account of seeing more systems that are capable of remote access, and where that is the case, then we have to ensure that the safety parts, the safety ready parts control systems, the SRPCS, remain operational when the machine is capable of remote access. And Clause 5 is determination of performance level required. That was in Clause 4 of Edition 3, so it's now in its rightful place in the specification clause. The guidance for that is still points you to Annex A. Annex A, the risk graph, the parameters are unchanged. The parameters are exactly the same as they are in Edition 3, but there is some additional guidance in Annex A about how to make choices between some of the parameters and the impact of that. That's intended to try and take some of the subjectivity out of the process. So there is a little bit of improvement there. And in Clause 5, it is mandated, it's a shall, that the safety requirement specification shall be verified against the risk assessment before we start the design. And of course, that verification has to be with some independence, has to be carried out with someone who's independent of the design. So clear instructions that we've got to have a specification, it's got to contain enough details, and it has to be independently reviewed. My personal view is that's a very, very significant improvement, because we know that from a study carried out by the UK HSE quite a long time ago now, but the recommendation from this study had a huge impact on what finished up in the generic functional safety standards, and it was found in this study that 44% of root causes when things went wrong that were associated with the specification in some way or another. So getting the specification right is essential. And that's been beefed up in Edition 4, which I think is a great improvement. I've already briefly touched on this, that there is more emphasis now in Edition 4 on achieving safety ready controls by combinations of subsystems. This is in fact another graphic from the standard saying that some functions can share subsystems, some subsystems contain more items, logic 2, output 2 within one subsystem in this graphic, and some subsystems that are used in safety ready controls can also be used by the non-safety controls and so on. So this specific clause in Clause 5, now 5.5, saying about decomposition of safety-related parts into subsystems. And also in Clause 5, I've already said that the requirements for categories and so on are pretty much as they were, but this, I think, is also quite an important change. For example, for Category 2, a category that gets some questions about it, some criticisms perhaps, but these measures about test rate to demand rate association and MTTFDs of various channels are now normative parts of clause 6. Whereas in clause 3, in edition 3, my apologies, edition 3, they were in a list of typical assumptions, which is all rather vague, but they are now there in a normative part of the standard. And also in clause 6, this concept again of this subsystematic approach, it is clearly stated, clause 6.2.2, that for the PFH of a function, the PFH of a function is the sum of the PFHs of the subsystems that make up the function. So the clause is called known PFH values. So where we know the PFH value of each subsystem, either because we've been given it by a manufacturer, because it's a certified safety component, perhaps, or manufacturers given it as a PFH value, we would use it. The measures in clause 6 about category MTTFD diagnostic coverage can be used to calculate the PFH of a subsystem. So for many functions, we would know the PFH of each subsystem. We also, of course, have to pay attention to any performance level limits that there may be on a subsystem, because we can never get a better PL than the lowest PL capability of any subsystem. But the statistical analysis of PFH for a function is summing up the PFH of subsystems. Clause 6.2.3 is now called unknown PFH values. And this is exactly as it is in edition 3. My personal view is that in edition 3, it's fairly clear that this approach is only applicable if we don't know the PFH values, although we know in practice that some people haven't seen it that clearly. So now it is very, very clear that we can use this table where we don't know the PFH of the subsystems. Yeah. So this is an alternative to using the known PFH, and it is saying that, you know, the best performance level you can get in a chain is the lowest performance level of any individual subsystem, and if you've got too many at that low level, you may have to drop a PL. So that's still in the standard. In my opinion, it has decreasing relevance. It is somewhat unusual that we would not know the PFH of subsystems today. And you know, particularly if we're using software tools to help us, like Systema, Pascal, Siemens software tool, and so on. They're designed to calculate the PFH of subsystems. Software, the new clause 7 is very much as it was. The V model, this is the full V model that's in edition 3, is only enhanced by making it clear that going down the left-hand side of the V is documentation exercises. So that's what the additional symbols are intended to show there. But the use of the V model is unchanged. It's described very much as it was. But there is now clarity that we don't always need every phase. We don't always need to do every activity, depending on the complexity of what we're doing and our starting point and so on. So edition 4 has actually got an example of a reduced, a simplified V model if we're using pre-assessed software. Pre-assessed software modules, either library modules provided by the system manufacturer or something that we could claim to have been shown to be proved in use. We don't need to go through all of the steps in the full V model. So that's explained. And this is particularly if we're using software, application software, typically using limited variability language. So the standard still retains some separate requirements for full variability and limited variability language, but it gives us some help. It gives us some help in how we can decide whether the software that we need to create should be considered to be full variability or limited variability. Clearly, the measures described for full variability software is more stringent than the measures required for limited variability. So we start by saying, are we creating application code in a safety PLC? There are some other things that would correspond to that top box, but that's pretty much what it is. Graphical programming languages, ladder diagram, function block diagrams, sequential function chart, those kind of things are considered to be limited variability language. So we go straight down the right-hand path there. That's LVL. But for everything else, we can go through those 4 questions. And if we answer no to any one of those questions, we've got full variability language. So we can only, if it's not graphical programming language in an application or safety PLC, it's something else, we have to be able to answer every one of those 4 questions with a yes for us to be able to consider it to be limited variability. So that's some helpful information about how we can make the choice between full variability and limited variability. Clause 10 is this completely new clause in 3849 Part 1, but it is based almost entirely on clauses 4 to 11 of 3849 Part 2. There has been some restructuring, a little bit of restructuring, so it's not just a copy and paste. But 10.1 as the principles of validation principles. 10.2 is saying we need to validate the safety requirement specification. That's supporting what it now says in clause 5, of course. 10.3, can we achieve some validation by analysis? And this is not new. This is exactly as in 3849 Part 2. The greater confidence we can get from our analysis can reduce the amount of testing that we have to do. But we can't eliminate testing. There would always be some need to carry out testing. So 10.4 is validation by testing. 10.5, validating that we've actually achieved the basic characteristics of the safety function. So we achieved, have we done the correct thing? 10.6, have we got the integrity that we required? Have we achieved the right performance level? And we applied the right categories, if that's also in 10.6, if a specific category was required. 10.7, looking after the environmental requirements. 10.8 is recording validation, having an audit trail, having a record that the validation has been done correctly. And 10.9 is validating the maintenance requirements. And there is a flowchart that summarizes the process of validation. This is the flowchart given in the standard. So hopefully a relatively easy to follow process. It requires a lot of care, a lot of documentation, of course, and everything carried out with some degree of independence. So you can't verify and validate your own work. So that's clause 10. And we do have a enhanced requirement to take care of the avoidance of systematic failures. So systematic failures are dealt with in the normative part of the standard in clause 6, amongst the aspects to be considered of the general overview of performance level, and we see this is bullet point F, so there's a few before this, but we have to consider the effective measures against systematic failure, and that goes on. It points us to course 617. That's telling us that systematic failures come from getting the wrong specifications, the wrong errors in design, manufacturing failures, and so on. But the guidance is given in Annex G. Annex G is an informative annex, of course, but there is additional guidance pointed to from the normative parts of Clause 6. And it's in Annex G where we get a mention, at least a mention, of the management of functional safety. Some people would argue that this hasn't gone far enough, but it does say that we should have a plan. It should be documented and updated, and the plan that there is a figure for in the standard that gives us some idea of what's required in a functional safety plan. It should identify the activities, roles and resources necessary, typical things that would be required in a formal functional safety management system, identify the procedures, and have an established validation plan, and identify relevant activities for carrying out any modifications. That's, again, a very significant thing, because, again, going back to that HSE study, which was a very important document in terms of what went into IC 61508, for example, it was assessed that 20% of the root causes were down to changes after commissioning, so modifications carried out. So having good change management in place is another way of avoiding systematic failures during modifications. So it's at least there. Some people would have preferred it if it was beefed up a little more, if there was more of that in the normative parts and so on, but we have at least got it mentioned. So now the annexes, the new annexes. I've already mentioned Annex A has been changed. The other annexes are pretty much as they were up to Annex K, but we now have new annexes L, M, N, O. And Annex L is another aspect of the standard that is giving some cause for concern in some quarters. It's about measures to fulfill electromagnetic interference immunity. And it describes 4 routes that can be taken, route A, B, C, and D, to achieve a sufficient immunity. You can see now that A, B, and D require us to go to other standards. In particular, EMC requires a relevant product standard for A, and 61600, 62, 6100, 67 for routes B and D. But it's route C, the part of route C, that is giving some cause for concern amongst some EMC practitioners. So some EMC experts are criticizing it quite heavily because it allows for making a claim of sufficient immunity without carrying out increased immunity testing. And what this describes is going to a table in Annex L, quite a detailed table, quite a big table, that gives a lot of measures that can make a contribution to giving some degree of immunity. The measures are scored, so this approach is the same approach as used in Annex F for common cause failure. And we take the scores to the measures that we can claim to have applied, we add up the scores, and the maximum possible is 390, but if we've got a dual channel system, we have to have scored 280, and then it says there are some other things in there as well, as you can see, but then it tells us that we have achieved the required level of immunity. without doing any additional enhanced testing. So this is just the last few entries in table L1. There's much more in the table than this. Most of the measures score only 10 or 20. There are only a few. I know there's 2 on the page now, but there's only a few. If you look at the rest of the table, there's only a few that score 30. So they've got to say yes to a lot of measures to score 280. But that's the way the route C is described in the standard, and that's what it is. Annex M is additional information that can help inform safety requirement specification. It's a couple of tables, but table M1 in particular, this is the top few entries in table M1, is pointing to other standards that will give additional information about the requirements of various safety functions, the functions that are individual functions that are described in clause 5 of the standard. So pointing to those are the standards, most of them B standard, type B standards, but it is just a pointer. It doesn't actually in Annex M describe any additional measures in itself, it just points to other sources of information. Annex N is a standard about avoiding systematic failures in software. It goes through a fully worked example about the steps that you would need to take to meet the requirements of clause 7 to avoid systematic softwares in software development. It is a simple example, it's true to say. It's just used for a safety PLC, but it's software, obviously. Used for a safety PLC with just a couple of safety functions. Excuse me. So that's the sort of diagram of the hardware structure. But then it goes through how to generate the software, how the software will be generated step by step, and that's supported by some diagrams as well. And I think it's a good example of the steps that you would go through. And although it is just a very, very simple example, the process could be easily followed by more complex examples. And finally, Annex O. Annex O is called safety related values of components or parts of control systems. It is pretty much the content of the VDMA specification 66413. VDMA is the German Machinery Manufacturers Association, and they produced an alternative data format for safety related data for subsystems typically that are going to be used in safety related controls based on XML files. And the content of Annex O is pretty much that. It does actually credit VDMA 66413, but this graphic I've included here is actually from the VDMA specification for 66413 itself. This graphic isn't actually in the standard, but all of those individual entries that you can see here in these various boxes are brought out into clauses and sub-clauses of Annex O. So that's 13849 edition 4. There are some concerns about some of its content. To be perfectly honest, I share some of those concerns in my opinion, but most of the concerns that are being expressed are also things that are in edition 3 that have been carried over into edition 4. So they're not new concerns as such, but overall, in my opinion, the new structure and the new emphasis on some of the very key aspects, I believe that 13849 edition 4 is an improvement on edition 3. But that's it. I'm going to take a look now at the list of questions we have. Sorry, but I'm just scrolling down the list here. Chris Johnson has been monitoring systems are used for diagnostics. They are also considered as going to have any criteria to comply with other than MTTF. Well, no, that's the, as far as I recall, Chris, that is the only time that monitoring systems have a specific requirement, but categories 3 and 4 are based on monitoring being performed within the subsystem or by another subsystem that meets the requirements of 13849. But you're right. The only category that specifies a separate monitoring system is category 2. So it is the only one that has any requirements, and that has been beefed up. That's now a normative part of the standard. Category 2 has had loss failure detected by the check is still present, because it always cause confusion in my customers. It seems that a Cat2 architecture should be able to detect any faults. Well, no, a category 2 architecture can be achieved according to the standard with low diagnostic coverage, and low diagnostic coverage is 60 to 90%. So that doesn't mean any or every fault needs to be detected. However, Claudio, I'm inclined to agree that we should be very, very cautious about how we apply category 2 architecture. And there are some elements that, in practice, in my experience, claims of category 2 architecture can be difficult to justify for a number of different aspects, and it is a category. There were issues about the use of category 2 architecture highlighted in CR 954 part 100. So some issues with category 2 architecture been there since almost the very beginning. It clearly has a pace, and one of the sort of contradictions that still exists in 13849, that in its scope statement, and this has been beefed up in edition 4, by the way, it says that the 13849.1 is not a standard for the design of products that are going to be used in functional safety. And in edition 4, it actually says that there are other IEC and ISO standards for those aspects. However, because particularly in Informative Annex D, it does talk about producing a product that is going to be used based on electronics and so on. There is a place perhaps for some aspects of category 2 that are used in practice, but my personal view, is just a personal view, is that we should be very cautious about making category 2 claims, because fulfilling all of the requirements of category 2 architecture can be difficult. Jake has asked, is an updated version of VN 3849.2 also expected? Yes, is the answer, Jake. Because the normative parts have now been, very good question, thank you. The normative parts have clauses 4 to 11 have now been taken account of in clause 10 of 13.849 part 1. The working group are now considering what should happen with 13.849 part 2. We can't lose it. That's very, very important. In particular, the annexes of 13.849 part 2 contain lots and lots of very valuable, very useful information, and there are lots of references to them from within 13.849 part 1, including edition 4, of course. So the annexes must be retained. One of the suggestions at the moment, but there's I don't think it's been absolutely decided which way to go, but one suggestion is that it will be revised and issued as a technical report. So it will be TR 13.849 part 2. But it's certainly going to be retained. It's certainly going to remain. Okay. And just going back through, don't think any of the earlier stuff is still relevant that I can see in my list. So no, I think we've answered the questions that have popped up in the chat right now, guys. If there are any other questions, please do drop them in the chat or drop us an email, and we will get back to you. That's the contact details about how to get in touch with us.